Hi there. Welcome to the machine learning module by using Python. So, machine learning is the perfect marriage between technology and science. It enables computer to learn from the data and make predictions without being programmed to do explicitly. So, the groundbreaking technologies has diverse application in different fields, including the healthcare and finance, and mentioning a few using the bioinformatics and DNA, RNA, and other things as well. So, we can use machine learning in this as well. Scikit-learn, explained with the PCA example, is the first uh, working directory that we are going to do, working module that we are going to discuss. Scikit-learn is a popular machine learning library in Python ecosystem. So it is used for the dimensionally reduction. So PCA is the dimensional reduction technique that can transform high dimensional data into lower dimensional representation while preserving its most feature. So using the Scikit-learn PCA algorithm, we can visualize a dataset with a reduced dimension with a reduced data frame. So if we move to the code section, we can see there is a code that is in the random forest. So let's learn about a random forest first. So if we move to, first of all, let's just see what a random forest is. I want to explain you a random forest. If we search for, it's a machine learning technique for the classification, regression, and other tasks operates by constructing multiple decision trees at a training time. So random forest is a machine learning algorithm that can be used for your classification and regression tasks. So in this code, we are going to use a machine learning library for generating some random numbers. So let's do that. So first of all, we will import the libraries, and after importing the libraries, we will clean the data. So we got a data with the files presented here. So what we will do, we have that data, and we will use that data. So the data that we are using is the names and data file for the breast cancer. So here we can open this with our notepad plus plus. So I can just show you, here is the a random data, a random generated data that is presented here. So we can use this to generate some random numbers. So first of all, we will import some libraries, your NumPy library, Panda library, your classifiers, and then your graphics. If you want to make this plot, make this as a plot as well. Then we will import some other necessary libraries and open the input file and open the output file for writing. Then we will clean the data by removing the line which contain the missing values, and after that we will close the input line. Then we will read the clean data and assign to column names. After assigning the column name, we will calculate the features and its importance. After calculating the features, we will calculate the accuracy of that classifier, and then we will print the accuracy by printing some random numbers. So 97.8933 is the accuracy. So 99 is the 100% accuracy that came for. If we can just look at all the results, if we can 80% accuracy, 50% is 96. So 96.91 a number is the 10% accuracy, but 100% accuracy come with 99%. So what is PCA? So as we were discussing that, so by using the PCA, you can add as classifiers. So clustering and PCA for sample classification. So by combining the clustering algorithm like dbScan and PCA, we can apply unsupervised learning to classify sample into distinct groups based on their similarities. Clustering can be used for the customer segmentation and personalized medicine and marketing as well. And we can also use the PCA that can detect anomalies or irregular data points within datasets as well. So what we will do here in this code we will first install the genomics section, which is the genomics. That is a module that is used for the genomics as well. So by using that, we will import some modules as well. After importing the modules, we will just print some random numbers that are based on our files that are present there with the Scikit-learn library. So because I can't generate all this type of data because it works on for example, if you want to get the output of it, it will give you the output of 150 gigabytes. So that's quite enough memory. I can't store that kind of data on my computer, but you can get this by assigning some single nucleotide polymorphism. You can get the SNPs, NDDs, and things like that by using the PCA analysis. So moving on to decision tree. Decision tree is one thing that I want to explore. It has a practical exploration in our field as well. So we can explore the breast cancer traits by using the decision tree. So decision trees are supervised learning algorithm that can help analyze the patient data and explore the traits that are contributing to the cancer diagnostics. Key factor the key factor that can impact is your tumor size, age, family, history, and other factors that can diagnose malignant or benign breast cancer. Decision trees can be provide useful insight into your patient data and highlight some critical traits of your data as well. So, as for the trees that we are going to use, first by using your random forest is an ensemble learning method that can improve the breast cancer output prediction. So, patient feature by analyzing a wide range of patient data, a random forest model can provide an accurate prognosis regarding the cancer output. Informed decision powered by machine learning, healthcare professional can leverage random forest model to make an informed decision on your breast cancer prediction as well. So if we move here, we can see that we get this data that is used in upper library as well. So after importing this data, we will clean the data and the column names accordingly, and then we will read that clean data. After reading that clean data, we will train that data. Training data will be purely based on our decision classifier, which is the random forest tree. And after that, we will output that fields onto the tree. So here you can see we have some based data. If I can just save this file and if we move to our output folder and we will see the data, we have the unformality cell, which is the 2.5, and the sample size is 683, and the class is benign. And by using this tree, you can interpret the result. The benign state then cause, and then 418 samples were then again classified, and they were also the benign cancer type. You can also move them to malignant by using this. So if you have cancer data sets, you can also predict that which patient is going to get the disease more early and which patient is going to get that disease less quickly or less. You can also perform clustering by using the machine learning. You can cluster the data sets, but again, it is a quite powerful technique and it needs a lot of resources. I don't have that resources on my laptop right now. It's in the workstation, but you can use this on other machine learning applications. So we have discussed the clustering as well. So what are the basic applications of machine learning? Machine learning helps in finance, natural language processing, in your healthcare, in your bioinformatics field, in your biotechnology field, and also in your marketing as well. So what are the challenges that are faced right now? First of all, resources. It needs a lot of resources. Data quality. Poor data quality or biased data set cannot make efficient prediction. Data privacy. Data are more sophisticated. Model interpretability. Some model need complex. They are interpreted by humans. And overcoming machine learning with data quality and pre-processing method can improve the data quality, and we can also check for errors and values, normalize data for consistency, remove the outliers. We can also use some data that is not available on the public. You can get this data from your local hospitals or things like that. And model interpretability is use simple models such as decision trees, random forest. Do not go for clustering methods, and that requires much more resources. Concluding, machine learning is a subset of artificial intelligence that is with the ability to read from the data. Scikit-learn is a popular machine learning library in Python which enable you to leverage algorithm and make accurate prediction. As machine learning continue to evolve, it will revolutionize the way we live and work by enabling intelligence application and intuitive interface. So that is pretty much for the introduction of AI in bioinformatics, a little guide about that. So thank you so much for your attention. You can get all these codes from my GitHub library and you can use them according to your own needs. And thank you so much for the attending the whole course.